Welcome back to my channel Study with Adu. So we are here back with another chapter. So I think that the fourth chapter, magnetism and moving charges, I may be doing it, but I don't know if I will get time to do it. But now I want to continue with the chapter magnetism and matter. This is a short chapter, but one question can be asked. 1 to 2 questions can be asked. Magnetism and matter. Okay. This chapter mainly deals with the theoretical concepts of a magnet. Okay. So the previous chapter was how a moving charge produces magnetic field. Now we are going to learn about this magnetic fields and how a magnet produces a magnetic field. Okay. And there are many things told, and one of the important thing is that the word magnet is derived from the name of an island called Magnesia. So magnet is derived from the word called which? From word called, because MCQ can come from here, word called Magnesia, where magnetic ore deposits were found. Okay, you have learned that a person kept his what's called a shepherd kept his metal stick that he used to used to control the sheep and all, and he kept it near a stone in Magnesia place in that island. And what happened, this rod, that is metal, I think it got stuck. It was attracted by that stone which he kept that stick with. So he understood that stone is having some attractive property, and that is a magnetic ore. So this is the story that's being told as the first attempt of understanding magnetism. Okay. Yes. Now let us look at some ideas in this chapter. Ideas means some concepts that this chapter mainly deal with. One is Earth is a magnetic field. Earth behaves as a magnet, not a magnetic field. Earth behaves as a magnet. It's a magnet. Pointing from geographic south to north. Okay. You know that always inside a magnet there is north and south. You know that always magnetic field lines go like this outside the magnet, right? But inside the magnet they are going from south to north. They are magnetic dipole, right? North is considered as positive and south is negative, and they form a magnetic dipole. So inside, the dipole moment is always from south to north, right? You know that dipole moment is from negative to positive. So inside the magnet it is from south to north. So they are telling us that in Earth, this is our Earth. Imagine this is our Earth. In Earth, this is geographic north pole. This is south pole, right? So the magnetic field of Earth is pointing from south pole to north pole. Okay, south to the north. Now outside Earth it will be like this. Understood? Okay, so understand. This is what the first line tells us. Now the next thing is when I'm not going to take a bar magnet and I'm freely suspending it, and I'm freely suspending it. So it will always if I am freely suspending it, it will always point towards north to south direction. What? North to south direction. The tip which point to the geographic north is called the North Pole. North. This north part point towards North Pole. And this south part points towards what? South Pole. So, if we don't know what is the North Pole and South Pole, we just suspend the magnet. Then we know it will stand in the north-south direction. Take a compass and look which is north, and find which side of the magnet is pointing towards north, and give that side of the magnet what? N, north as the side, and the other side will be south. That's what it's told. Now third one is like poles repel and unlike poles attract. This is a very common one that everyone knows. Now another thing is that, now next point is that magnetic monopoles doesn't exist. Magnetic monopoles does not exist. That is, look, if you take a magnet, I am taking a magnet. Why this look like that? I'll take a magnet. I will take this as a magnet. And this magnet, every magnet will have a north pole and south pole. That if I am cutting this magnet into two, look, you have seen that there will be a sign like this. This part north will be in what? Red, and this will be in green. Now what I am going to do is that I am going to cut this. Cut this magnet into two. I cut this magnet. Now what happened? Does this magnet become only, this magnet is only north and this magnet is only south? Does this become? No, this is not possible. If we cut this magnet, what happen? You know, this cut magnet will become another bar magnet, or a magnet with both poles. That is, this side will have north and this side will have south. This magnet will change it to this side having north and this side having south. So this is what going to happen when we cut a bar magnet. That's the reason why never you can see a south pole is independently standing somewhere, or a north pole is independently standing somewhere. This is impossible. That is, magnetic monopoles doesn't exist. Always a magnet exists as what? North-south pair or dipole. Magnetic dipole. Okay? Yes. Now it is possible to make magnets out of iron and its alloys. This is just note it. We can produce magnet from iron and its alloys. The thing is that iron and its alloys are ferromagnetic. Okay, the thing is that these iron, look, you have learned in chemistry, a D block elements chapter, you have learned that in iron the configuration of electron is like this, right? They are having unpaired electrons, many unpaired electrons. So as unpaired electron increases, paramagnetic character increases, right? Paramagnetic character increases, and when it is in iron, this character is called ferromagnetic character. That is high attractivity. Paramagnetic is feebly attracting, and ferromagnetic means what? Highly attractive. So iron and its alloys are having ferromagnetic characteristic that we can convert them into what? Magnets. Okay. Yes. Now, one second, sorry. Yes. Now we have Some examples of magnet. That is natural magnet. You know, in earth there are many types of magnet. There is natural magnet that are like present inside the earth itself. We don't have to create it. Example is manganite ore, magnetite ore, Fe3O4. This is a natural magnet existing in our earth. Okay, yes. Now another example for artificial magnets. Artificial magnets are the thing when iron and its alloys are kept or are electromagnetized for a long time. They will gain magnetic properties. This is called as artificial magnet, that we are artificially creating these ones, right? So that is about artificial magnets. Now we told about basics of magnet. Now we come to the important magnetic dipole.